been forgetting to do this frequently. And I'll go right into sharing screen here. Clean this little thing up here. Down here somewhere. So we're talking about the shuriken particle system, and we're talking about the different modules. And there's the main module, which is basically how the particles start. This gives us things like the start lifetime, the start speed, the start size, the start color. All of these things are what our particles look like when they originate. An important one is the simulation space, whether it's local, in which case all the particles will move around relative to their to the system, or world, in which case they move around in the world. If we have a moving system, we would want to use world unless we wanted the particles to follow that object. There are a lot of different settings, of course. The different modules, all of them come with emission, shape, and renderer. Emission, making the particles shape, the shape of the object from which the particles come, and the renderer, which has the texture that we're going to apply to our particle. But all these others affect the behavior of our particle over often lifetime. So we see all these velocity over lifetime, force over lifetime, color over lifetime, and so forth. We also have the color by speed, size by speed, and rotation by speed. And I warn you that these are exclusive with the over lifetime ones. You can't have both color over lifetime and color over speed. Only one of them will be active. So the emission mode, we had the three different ways of doing it: rate over time, rate over distance, and the bursts. With bursts, we specify how many times we do it, what the interval between bursts is, and what the probability of a burst occurring is. So these don't occur 100% of the time if you don't want them to. Also, when the burst occurs. And we can have many bursts by adding more of them there. The shape module, we went through, had all these different shapes: the cone, the sphere, the hemisphere, the torus. There are lots of different shapes that you can emit your particle from, and each of these will affect how it behaves. That start speed that we saw up in the main module, this is going to be different depending on the shape. The cones emit out through the cone, the spheres emit away from a point in space. We saw velocity over lifetime, which was just a setting that we could apply. Here's kind of an interesting one. If I do force over lifetime, no, I want velocity over lifetime. I want velocity over lifetime. The velocity over lifetime has this orbital velocity, so I can make the particles swirl different ways. I want to do it around the z-axis. So we can apply these orbital velocities that make it swirl. And lots of different effects, all of which can act together to make very complex behavior. There's the noise, and noise is just a nice handy way to, let me close that. Noise is just a nice handy way to make your particles not so deterministic, not so moving in a straight line. And the noise samples from this Perlin noise, which has a scroll speed. We're sampling noise from that black and white figure. And if I scroll, it moves across this thing and samples different places. And so the noise is always a bit different. We have things like the number of octaves, the octave multiplier and the scale that also affect this, as well as the strength and the frequency. If I set the frequency down to 0.25, it's lower. If I set it up to 0.75, to 1 or to 2, it becomes much higher frequency. 0.5 is a good one. So noise is a good way to add some jitter into your particles so that they're not so deterministic. Limit velocity over lifetime is just what it says. It doesn't let the velocity of our objects get any faster than a certain speed. This is kind of a way of doing drag so that particles don't accelerate forever. Inherent velocity is kind of interesting. Let me switch scenes here to, I think it's this one. Don't save. Here I have a little particle which is emitting over distance. So it's emitting at a rate of 1 per distance. And so no particles are being emitted over here until I move the little object. And this has an inherent velocity of about 0.25. And so as I move this thing, the particles are inheriting some fraction of the velocity of the particle system that's moving through space. So inherent velocity is a good one. Back to this one. Don't save. So let's see, force over lifetime. And again, force is a vector, so we can modify the X, Y, or Z forces. And this is an example using the curves. If we do force over lifetime here, force over lifetime, I have the potential to put in curves. Curves appear down here in the curve editor below, which by the way is a dockable window. So let me fiddle with the Z curve. And this has, damn. I gotta close that up because the zoom thing is on top of it. So we have various presets for the curves. Here I'm applying it plus or minus 1 over lifetime, and I can scale this up so that it's twice as big. So over lifetime, the particles are going to move first one way, are going to be forced first one way, and then the other over their lifetime. Turn that off. Color over lifetime, I think I already talked about. This is an important one for having your particles not pop out of existence. With color over lifetime, we use one of these gradients that lets us apply different colors over time, and also the alpha channel along the top that controls the visibility of our particle. Color by speed, which is what I have set up here, changes the color based on how fast the particle is going. Size over lifetime, like force over lifetime, is potentially a vector. Most of the time we would not use separate axes because our particles are billboards that face the player. And there's also a size by speed. So as your particles move faster or slower, you can change their sizes. Lots and lots of different options here. Rotation over lifetime, the particles I'm showing here are axially symmetric. They're little balls, so rotation doesn't really affect them. I believe I might have a little snowflake here, a little snowflake system. The little snowflakes, rotation would affect them, and you could make these little snowflake particles spin over their lifetime. That's also something that you can set in the main module. You can set the rotation speed of your objects, of your particles. Let me turn that back off again. Rotation by speed, again, the particles spin based on how fast it's going. External forces is an interesting one. External forces lets our particles respond to wind zones, which are things we can put in our world that will either blow horizontally across the surface or radially out from a particular point. And those wind zones have turbulence in them. So they're not just a uniform wind, they're like time varying wind. And so you can make your particles blow around and respond to that wind. They can also respond to force fields, which are kind of an interesting one. Here's a force field. Don't save. Here's a force field that I've put up. And I put a little transparent bubble around it so that you can see the range of the force field. And these particles, as they rise up, when they enter the force field, they begin to respond to the settings of that force field, in which case here it's gravity that pulls the objects towards the center of the force field. But you can do all kinds of strange things with force fields. They're very powerful tools that you can put in your world, and when a particle enters it, something interesting will happen. That's done with external forces. The collision module, again, I've shown you in this example here, we have a collision module on our particles. They're colliding with the world, which means they collide with everything. There is a mask, a culling mask for what they collide with. So you can have them collide only with specific layers. And a less expensive setting is the plane setting. And the plane setting, we enter a plane here, and then the particles collide with an infinite plane that is parallel to that. Whoops, I didn't get the object into it. They collide with this infinite plane that has the orientation of this object that I've placed in here. The reason one does this is that collisions with planes is much less expensive than collisions with the world. With the world, it uses a ray cast, and with the planes, it uses geometry. And so in one case, it's computationally less expensive than the other. Collisions we'll see used in a number of different demos that I have here. The mesh trigger and the snowstorm both use collisions. And in both those cases, we do something with the collisions. In the case of the mesh trigger, save. In the case of the mesh trigger, here I have these objects And I'll show you this when we get to the renderer. Instead of rendering particles, I'm rendering actual meshes. They're colliding with the world, and we're doing something with that collision to keep track of how many have hit the world. I've got this little UI that's counting up the number of hits, and I'll show you that in a minute. So the collision, again, the plane is very efficient. The world is much more computationally expensive. And there are also quality settings that, make it less expensive or more expensive, but low and medium tend to leak. I'll show you examples of that some other time. Now, the way I did that, that example with the bouncing balls was using the trigger module. And the trigger module lets you sample collisions with other objects. And if you have a collider, and we'll talk about colliders when we get to physics, that's set to be is trigger, which means it's a trigger, we can do different things depending whether our particles are inside the trigger, outside the trigger, have just entered the trigger, or have just exited the trigger. And the kinds of things that we can select are to kill the particle, to ignore the particle, or to trigger a callback function. And that's what I've done in this one. The collisions with the ground that these balls are hitting is triggering a callback function in a script that's on the particle system. And it's a little early for us to do scripts, but I believe here's kind of the script that I'm using here. And there are a number of different elements here that we'll talk much more about, in particular the UI, the text that I'm displaying this in. So we'll ignore this stuff here. I have a list of particles, particle system.particles, and a list. You have to have the system collection generic to have access to it. And here I'm getting into PS the particle system, and then the on particle trigger gets the trigger particles from of an event type enter, and it returns them into that list enter, which I then just increment my count by the number that have entered that trigger. And so that's then displayed in the little text here. So that's an example of a trigger. I think there's another trigger here. In this case, the trigger is this box that I've put a little transparent material on. It has a collider that's set to be is trigger. And when the particle system plays, the particles as they enter the box turn red, and as they exit the box, they turn green. And they're blue to start with before they've entered this trigger. So we can do lots of really fancy stuff with fairly simple scripts. That this example over here is from the documentation, from the on particle trigger documentation in your manual. Subemitters, here's where things get really powerful, because with subemitters, we can start to make particle effects. A particle system is a single system that makes a suite of particles. But with the subemitter, when certain events happen to a particle, an individual particle, we can then trigger other particle systems. And we have birth, when the particle is born, death, when the particle dies, collision, when the particle hits some object, and then there's trigger and manual, where you do it. A trigger is a little different than a collision, and a manual is something that you do yourself from scripting. So I have this scene here, and this set of A zeros walks you through the buildup of this little emitter system that, when we're finished, is going to look like this. It's going to look like something where particles come out, they leave trails behind them. When the trails die, they leave little red sparks. When they hit the ground, they leave a little splat texture, and when they die, they make that little blue explosion. And so this is all done here. I have this basic particle system that's emitting these particles. And let me get kind of a side view here. So this little system is emitting particles. And I've pre-made a bunch of different things here. There's the particle system that I just showed you. That only makes particles when it moves. And so I'm going to call that, I'm going to rename that trail, just so I know what it is here. Now in this particle system, I'm going to add the subemitter. And let me drag this down and close this up. And so I have the subemitter here, and I'm going to pick a birth. So on birth, I'm going to add that trail system. And when I add the trail system, it asks me this question: do I want to reparent the game objects? And generally one says yes. And watch what happens over here when I say yes. The trail system is now a child of the particle system. And so we've begun to make a particle effect at this point. I now have these things all together in one object. And this means that I can open the particle system editor, which has those two particles displayed side by side in a window, a dockable window that you can fiddle with. And this is a way of taking care of the different things that we've got here. Now, let's see, the next one I've got here, I've got this little effect. Where are we? I've got this little effect, which I believe is a little simple burst of 5 particles. Notice here it shows how many particles are being emitted by that thing, 5 of them. So I'm going to call this red burst. And I'm going to make this a child of the trail. So the trail, I'm going to add a subemitter to. And on death, I'm going to add the little red burst to it. And I'll again say yes, reparent. And now the red burst is a child of the trail. And my particle system, let's play it and have a look at it. Where are we? Our particles are coming out. They're leaving this little white trail behind them. When the trail dies, it's giving off this red burst. And so we have this particle system now that, again, I'll remind you, we can open the editor and we have all 3 of these effects side by side. And that's a dockable window. So let me go back to this original one here, and under subemitters, I have this one. And this one is just a little splat. It makes one particle, and the one particle just grows with time over its lifetime. Restart, it starts small and it grows. And so I'll call this the green splat. And for my particle system here, I'm going to add an event, the collision, and I'll add that green splat to it. And I'll say, yes, reparent. And it's now a child of the particle system. And my main camera is getting wonky here. Why my main camera is getting wonky. I want it to look at the world. So now when my particles are hitting the ground, when they're hitting the ground, they're leaving this green splat behind. So one more little piece, I've got this little piece here, which is just this blue burst. And again, I'll add an event here, this time on death, and I'll add sub3 to it on death. And so, yes, reparent. There it is reparented. And let me line the camera up properly to begin with here. Align with view. Okay. So I've got my original little snowflake particles coming out. I've got my original little snowflake particles coming out. They're leaving the little white dot trails. When the little white dots die, they make the red splat. When they hit the ground, they leave the green thing. And when they die, ultimately, they make the blue thing. In here, when we're in the scene view and we're looking at this particle effect thing, one, you can control the speed. So I can make my particle system run fast or slow so that I can look at it in detail. It shows the number of particles and the number of subemitter particles that are out there. If I have show only selected here, I can see just one little piece of this. So here I'm only seeing the trail. Here I'm only seeing the red bursts. Here I'm only seeing the green splats, and that's with this thing selected. So all of this lets us do fancy things with our particle system. And this is the subemitter, and these are particle effects. And they're very, very powerful tools. And I'm going to pause here and entertain questions if anybody's got any questions on that one, because that's a really high test kind of module.
I have a question.
Okay.
For when you reparent the particle systems to each other, is there like a limit to how many times you can do that? Of like the hierarchy of reparent?
No, and I think you can actually use the same particle system in multiple places. So
oh, wow.
You can have that red thing not only be the death of the trail particles, but you could have it be the collision with the plane on another particle. I don't think it reorganizes it when you do that, but you can use it more than one place. You can also just make a copy of the original and have have two copies of the same particle system, in which case they would then child properly to the right module.
Thank you.
Answer your question?
It did, yeah, thank you.
Anything else? The sub-emitter system is tremendously powerful, and I believe the Unity, don't save, the Unity sample asset fireworks is kind of a tour de force example of a particle system that uses sub-emitters. This fireworks system has smoke that spawns sub-emitters, that spawns secondary trails, and trails that spawn tail afterglows. You know, it's a very complicated system. And in the editor, we've got all the different modules here available to make it easier to kind of edit and control things. And this is, of course, a dockable window. I think I actually have a layout that's set up for particles where that docked window is part of the standard layout. So that's the sub-emitter. Now, the next one is the texture sheet animation. And let me stop this over here and go back to my scenes and texture sheets. And here I have a bunch of different little texture sheet particle systems that I've extracted from the fire complex. This is a particle system that comes with standard assets. It's this really nice fire that makes smoke and sparks and all kinds of other stuff going on. It's a fairly complex.
We can't see your screen, by the way.
Oh, I'm sorry. Yeah, thank you. Anytime I screw up, please tell me, because it doesn't do you any good when you can't see what I'm doing. So, so what I'm showing here are a bunch of little texture sheet particle systems that I've got here. And each of these only makes one particle. So this one that I'm looking at here, this flame thing, is a single particle that has a lifetime of 5 seconds and 0 velocity and manifests in a particular place. But it has the texture sheet animation here. And the texture sheet animation takes a particular texture, and the texture I think is put in where do we put the texture sheet in? Oh, here, the particle flames. So it comes from this material. And this material is a sequence of little tiny pictures of the flame as a function of time. And this is a texture sheet that has lots of little pictures. And in this animation, in this texture sheet animation, I have to specify the number of tiles in the X direction, and there were 8 of them, and the number of rows, and there were 4 of them. And then there's some settings for how it cycles through them, whether it does it by speed, lifetime, or frames per second. I'm asking here for 30 frames per second, which frame it starts on. And so that's how this little flip sheet is doing its animation and making these realistic looking flames. And I've got a bunch of others here with different textures, most of which I think I extracted from the fire complex. So these are all ones that are being used by the fire complex to do different things. And so a lot of these animations just put out a single particle, billboarded to the player, and then step through the different animations or through the different images that are recorded in that little texture. And there are a whole bunch of them here that I've extracted from standard assets. And so now if I play this thing, I can see all these different particle effects that are just single particles, and they're billboards, of course, so they always turn to face me, but they're all part of this fire complex that has all these different pieces going on inside it, making this realistic looking fire. So that's all pretty cool. Texture sheet animation. Now, another cool thing we can do with our particles is put a light on them. And we need to have a prefab object light that we're going to include here. We have the ratio, how many of the, what percentage of the particles will get lights. They don't all get lights. You can have like 0.1 means 10% of the particles get lights. 1 means all of them get it. And of course, lights cost things. So you want to be careful. There is a maximum light setting for the maximum number that you're going to get. And we can affect the range and intensity of our lights with the range multiplier and intensity multiplier. Also things like whether to use the particles color, have the size affect range, and various other things here. And I have a scene here, my snowstorm scene, in which I have particles that have lights. And one thing to remember is lights only affect, only cast light. We don't actually see the light itself. We see the light that hits a surface. So we don't see the lights until these things get close enough to the surface to make that red glow that is underneath the snowflakes when they hit the ground. Incidentally, there's a lot of sub-emitter stuff going on here. And there's another effect here that I'm using, which is the trail. You notice these snowflakes as they fall have these lines coming out of the end of them. And that's a trail, which is another of the modules that we have available to us, the trail. And the trail is actually an example of a legacy particle system, which I never really talked about. The legacy particle system disappeared in 218. It still works in 217 if you want to go look at it. And the two remnants of the legacy particle system are the line renderer and the trail renderer. And the line renderer, let me see if I have I think I have something in here. It's so slow when Zoom is running. So I think I have a line renderer here. Where is it? Oh, I've got to be in the line scene. So I have a line, I have a couple of lines here. One, I've made a circle line. Here's a little square. With the line renderer, you specify the number of vertices that you want to have on the line, whether it casts a shadow, whether it's done in the world or locally. If it's done in the world, the coordinates of your points will put it out in the world. I have these animated, of course, so that I can turn them. notice that they're billboards. So they do kind of funny things when they turn sideways to the camera because they're always trying to face the camera. But those are lines. The trail here, I've got a trail on this ball, and the trail has a particle texture on it that is the little fire texture. And one of the interesting things about the trail is it has a destroy when the object stops moving, when the trail disappears. And so if those balls ever stop rolling, which they don't always do. See if I can get in the way here so it'll stop. When that trail completely disappears, it'll destroy the object. Maybe it's the other ball that will destroy. There, it destroys it. So this is kind of handy for, you know, bullets or other things that you leave a trail when the bullet hits the ground and stops and rolls to a stop. Instead of you having to clean it up, when the trail is gone, it'll disappear by itself. Trails have a length of time that determines how long they are. They last a certain amount of time. So as the objects are rolling around, that trail is the length of its, it extends out how long it goes here. So those are the legacy objects here, but we can put these on our objects here. So in the snowstorm scene, the original particles here have a trail renderer. There are different modes. I'll let you play with them. One of the things you have to do is include a trail material here in the renderer. You can have color over trail. So I go from this purple to white. So you see the trails have different colors as they're falling. You can set the width and some other settings that I'll let you fiddle with. So trails. Custom data I won't talk about. This is more advanced stuff for other things. Now, the final thing, the final module here is the render, which I've alluded to in a couple of different settings above. One is the render mode, and the render mode determines how these little particles are presented to the camera. The billboard takes our little rectangle that has our particle on it and orients it so it is always perpendicular to the camera. So no matter where the particle is, it appears face on to the camera. And this makes these particles kind of look three-dimensional because as we move around them, they continue to face us. Other settings in the splats here, in the splats that are being placed on the ground where they collide, I'm using a horizontal billboard. The horizontal billboard makes the particle horizontal. And there's also a vertical billboard which puts that holds the billboard in a vertical upright. It still faces the camera, but it doesn't tilt if the camera is above it. It holds it in kind of a vertical setting. But this is also where you specify the mesh mode. And the mesh mode is what I used back in that trigger example where I had the red checkerboard balls bouncing around the scene. You can put whatever mesh you want in the mesh mode, and our particles now can be actual meshes. You could fling lerpses around the scene and have him bounce off the world. So billboard, horizontal billboard, vertical billboard, stretched billboard is one where the speed of the particle affects how the billboard is stretched in space, and the particles align with their velocity as they're falling. And the horizontal billboard here should reference the snowstorm scene, not that one. So the renderer, there are lots of different settings. Sort mode, transparency is hard. And so things that are transparent in front of other transparent objects can look weird because the depth, my dog, the depth of transparent articles. Liba, shh, quiet, sorry. And so we can spend a few extra cycles by sorting them from oldest to youngest, or by distance. And this will alleviate some of the artifacts you'll see with overlapping transparent things. And there are lots of different options. Now, I've already talked about particle effects, but particle effects are where things get really interesting because we can build this cascade of effects, and they don't actually have to all be subemitters of each other. You can just child different particle effects to the root particle effect and have them be part of the effect. And this also gives you access to that particle editor, which shows you all of the different systems of your particle effect in a single editor with access from the inspector. And that's very cool. And I highly recommend the standard assets fireworks as an example of a complex particle effect that you can study. You can take it apart and figure out how it works and learn an awful lot from the particle effects. Incidentally, I didn't mention it, but the particle effect has this curve window below it where all of the different curves are visible. This thing about toggle show all show selected, I think it disappeared, for at least from Unity 2.19. So the only way to access that is with this little button over here, and various orderings of different things are available. So I'm going to stop sharing at this point with 2 minutes remaining in class, and answer any questions for anybody who's got them. I'm sure there must be some. Let me look at chat and see if there's anything burning over there. Your screen isn't shared. Thank you for telling me that, except I don't see chat. So any questions? So have fun making particles. And I'll remind you that you're welcome to include particle systems from that were made by others, but what I will grade will be the particle system that was made by you. So that's what I'm looking for, is you to create a particle system.
I have a quick question on the assignment.
Yeah.
Does our particle system have to have like subemitters and multiple sets of particle systems and stuff like that?
It doesn't, but I give bonus points. I mean, I give points for people who, the more you try, the more complex your system, the higher the grade. I'm somebody who just puts an unmodified particle system in a scene and hands that in, doesn't get a lot of points. It's when you
That's fair.
do things, it's when you do things with it and be creative that I award points.
Because
My
what
grading
I'm working
system
on,
is based more on addition than subtraction. I kind of start off with a base grade and then I add points as you do more stuff. Go ahead.
okay. Because right now I'm working on a smokestack for a train,
Okay, cool.
right? But I'm trying to get it so that if the particle is moving, then it acts like the smoke is billowing off in the opposite direction of where the train is moving, right?
Okay,
And I remember you did something like that where you were moving the particles and the particles kind of stayed and billowed a little bit.
right.
What was the setting that you used to accomplish that?
In the main module, it's simulate in either local or world. And if you want your particles to be left behind by your moving train, you want it to be in the world, because if it's in the local, the particles are just going to come straight up from your smokestack and move along with your moving train as this vertical column of unrealistic smoke.
Yeah.
But if you simulate in the world, then as your train moves, the particles will be left behind. And that inherent velocity thing, you can set the smoke particles to inherit some fraction of the velocity of your train that's moving the particle system. And
Okay.
so the smoke will kind of billow along with the train for a little bit. If you set that to 1, it'll completely follow the train. And if the train turns, the smoke will keep going straight, because once it's started, it keeps the velocity that it's got. So you definitely, but I think the world setting and a little bit of inherent velocity and your smoke would look pretty realistic on your moving train.
Awesome. Awesome. I appreciate the input. Thank you.
Put some sparks in it too. It's a
I
steam
was thinking about
locomotive.
that.
Is it a steam locomotive?
It's kind of the idea is where I kind of got the idea from. But what I'm having trouble is making the color realistic.
Yeah.
Because if you look at like a train, like Smoke's train, if you use like the color dropper, you see a lot of like deep blues and purples, sometimes some yellows in with the black smoke, and it's hard to simulate all of those different colors in a single particle system.
You use more than one.
What if you use a gradient? There's
the
a color.
gradient works okay, but by the time I get to the end of the gradient and I try to change color, it goes for this thing where it kind of blinks in and out of existence.
Yeah.
So it'll like blink down to where I set the gradient to be the color at the end of the gradient, and then it will fade away. And it just keeps blinking, which is not like the stuff what I'm looking for, right?
Well, there's I believe there's a feature you can make it so like the particles are almost kind of like a random. So like you could and I believe there's a way to like implement certain colors at like certain points along it. So like that might kind of, I don't, it's
Okay.
there's something like I'm not explaining it well, but I believe there is a way in like the color gradient to make it say like you can at certain times implement like, oh, you like certain colors along the gradient,
Yeah.
So in the main
which
Okay.
could kind of work.
in the main module, there's start color. And the start color can be a gradient. You can make a gradient that has a whole bunch of different colors across it. And if you just leave that alone, the particles are the particles are emitted over the duration. That time setting in the main module are emitted as different colors along that gradient. However,
Okay.
there's a setting where you can say random from the gradient, and it will pick colors randomly from that
Ooh.
gradient. And that might give you more variation in your color. And this is the start color of the particle in the main module of your particle. And
Okay.
and I think that then color over lifetime might not work as well as you'd want it to. I think the color over lifetime, you know, if you've like
I
color
was
over
I was thinking
lifetime
more.
kind of adds to the start color that was there or replaces it. I can't remember which. But
I was
you're
thinking
gonna run
more
into
color
some
over.
issue with that, with color over lifetime.
I was thinking color over speed might work well,
Yeah,
considering that basically you're looking at like when the smoke dissipates, it's when it starts to slow down.
okay, so you'd want to put a limit velocity on your particles that had some drag that would slow them to a 0 speed. If they're emitted with some velocity, they keep that velocity for their entire lifetime unless you set velocity over lifetime goes to 0 or limit velocity with some drag that slows it to 0. But otherwise, particle velocities keep going unless gravity pulls them down or unless you you limit velocity or you have a velocity over lifetime that slows them to 0 as their lifetime expires. That's a good idea to have their, you could also do size by speed so that the particles got smaller as they slowed down. Size by speed. Lots
Okay.
of different, this is a TMO. There are too many options. and
Yeah, absolutely.
it's fun. It's fun to have all these options, but it does make
Playing with it a little cumbersome.
Ryan, you have a question. Do you allow resubmissions of previous assignments for a higher grade? I'm assuming late penalties will apply. That's exactly the way I work it. So if you want to resubmit, I actually, you know, 80s and above really don't get much by resubmitting because, you know, they lose points for the timing. But if you're in the 70 category, definitely do that. Did you get that, Ryan?
All right. Well, thank you, Professor. You have a great weekend.
Okay.
Thank you. Have a great
fun.
weekend.
Have fun doing homework.
Oh, one quick question before I skedaddle. For the scene, does it matter what the scene is? Like,
No.
I just put mine in like I just created like a random terrain with a forest and like put the campfire there.
That's fine.
All right.
I don't grade the terrain and the lights and everything now. I just grade the particle system.
Awesome. All right. Thank you.
Okay,
Have a great weekend.
have fun.